Hello everyone, this is Mrs. Snook with section 5.2, Verifying Trigonometric Identities. And what we're going to do in this video is we're going to verify trigonometric identities. Now this is the type of thing where I can't tell you specifically, first do this and then do that. I can tell you it's going to involve algebra and rearranging. And you're also going to need your trig identities. So grab that handout and let's get going. First of all, I'm going to give you some tips for success. I call these Snook's rules for success. Work with one side of the equation only, one side. Usually it's the left, but every now and then the right will work better. You need to look for opportunities to factor, to add fractions, find a common denominator, things like that. Use the reciprocal identities in all forms of the Pythagorean identities. Sometimes it helps to convert all your expressions into sines and cosines. Don't give up. This can be a bit challenging, but never surrender. If one idea doesn't work, try another one. And as always, I am here to help you, so feel free to seek me out for help. All right, here's our first one. We're going to verify the trig identity. So in our numerator, we have secant squared x minus 1 over secant squared, and that's going to equal sine squared. So by verify the identity, what I mean is rearrange one side and make it match the other side. So I am going to focus on just the left. So this is the only side I'm going to work on is the left. I'm going to keep the right the same every single time. All right, so the first thing I am going to do is I notice that I have secant squared theta minus 1. And if I put in a Pythagorean identity for secant squared, this is what I get. I get tangent squared theta plus 1. I'm plugging that in for secant squared, and then I still have the minus 1. So secant squared theta equals tangent squared theta plus 1. That's the identity that I'm using. My denominator, I am going to leave that for now as secant squared theta. And I'm not changing my right side at all. So sine squared of x. Oh, I'm sorry, I switched variables. It's x and I went to thetas. Let me fix that for you. All right, now the next thing I do is, do you see the plus 1 and the minus 1? Well, those undo each other, so now I get tangent squared x over secant squared x equals sine squared of theta. Again, no change to the right-hand side. Now, I know that secant squared theta is 1 over cosine squared. So secant squared of x is 1 over cosine squared of x. So I'm going to plug that in, and I get tangent squared of x over 1 over cosine squared x equals sine squared x. Now when I'm dividing by a fraction, that's the same thing as flip it over and multiply. So I get tangent squared x times cosine squared x equals secant squared x. Another one I keep in mind is that tangent squared is sine squared x over cosine squared x. So now I'm going to plug in my sine over cosine. So this is where converting all your expressions into sine and cosine is helpful. So I get sine squared x over cosine squared x times cosine squared x equals sine squared x. And I don't know why I wrote secant there. I'm not changing my right side at all. Now the cosine squareds, they cancel out, and I have sine squared x equals sine squared x. That's what I want. I have made my left side match the right side, so I have verified my trig identity. Here's another one. We're going to combine fractions before using identities. So that's a hint for this one. Now notice that the fractions are showing up on the right-hand side. So we're going to use the right-hand side this time. And we're going to combine our fractions first. So 2 secant squared of x equals, I'm not going to change the left at all this time, I'm just going to change the right. And what I'm looking for is a common denominator. Notice I have 1 minus sine x and 1 plus sine x. If I multiply these together, 1 minus sine x times 1 plus sine x, I'm going to get a difference of 2 squares. So I'm going to get 1 minus sine squared x. So that's going to be my common denominator. Okay. That means that this 1 in this numerator, I have to multiply it by 1 plus sine of x. So I get 1 plus sine of x. This second fraction, I have to multiply this numerator by 1 minus sine of x. So I get 1 minus sine of x. Now that they have the same denominator, I can go ahead and combine them into 1. So I'm going to have one denominator, 1 minus sine squared x. Notice I'm keeping the left side the same. Combining 1 plus sine x plus 1 minus sine x. Now check it out. I have a plus sine x and a minus sine x right there. Those drop out. So that leaves me 2 over 1 minus sine squared x. So I'm getting that 2 already. So you see I've got a square and I've got a 2, so I'm getting pretty close. So let's go for a Pythagorean trig identity. This is the one I like to use the most. So sine squared x plus cosine squared x equals 1. That's my trig identity. What happens if I subtract sine squared x from both sides? I get cosine squared x equals 1 minus sine squared x. So I can plug that in. So now I get 2 over cosine squared x. And keep in mind that secant of x equals 1 over cosine of x. So then secant squared of x equals 1 over cosine squared of x. So now look at that. Right here, I have cosine squared of x in the denominator. So that becomes secant squared x. So 2 times secant squared of x, that's my right side. And that matches. Check. We have now verified that identity. All right, so here I have this one. Notice I have a tangent squared x plus 1 and a cosine squared x minus 1. Well, remember we have some trig identities that we can use. So let's use our Pythagorean identities. 1 plus tangent squared x is going to equal secant squared x. So I'm just going to substitute that in. Cosine squared x minus 1. So let me show you where that comes from. So you have sine squared x plus cosine squared x equals 1. So if I subtract 1 from both sides, actually, no, let's do it this way. Let's subtract cosine squared x from both sides. Then I get sine squared x equals 1 minus cosine squared x. Now what I have in my identity is cosine squared x minus 1. So if I multiply both sides by negative 1, I get negative sine squared x equals negative 1 plus cosine squared x. And then I'm allowed to flip this around. So this is cosine squared x minus 1 equals negative sine squared x. So for that reason, I'm going to put negative sine squared x here, and this says negative tangent squared x. I'm keeping my right side the same. I'm changing the left only. So secant squared, remember that's the same thing as 1 over cosine squared. So I get negative sine squared x over cosine squared x equals negative tangent squared x. And reminder, tangent is sine over cosine. So I have a negative sine x over cosine x. This whole thing is squared. So negative tangent squared of x equals negative tangent squared of x. So check, that one's done. Now here's an example where we're going to want to convert to sines and cosines first. So check this out. I have tangent and I have cotangent equals secant times cosecant. So let's convert to a sines and cosines first. So tangent of x, that's sine x over cosine x. Cotangent of x is cosine x over sine x. And that's going to equal secant x times cosecant of x. Let's get a common denominator. And my common denominator is going to be cosine x, sine x. All right, so my sine x in the numerator, I have to multiply that by sine x. So I get sine squared x, right? Cosine x in this numerator, I had to multiply by cosine x, so I get cosine squared x. I can now combine into one denominator. Cosine x, sine x, that's going to equal secant x, cosecant x, making no change there. And I have sine squared x plus cosine squared x. Well, that's a trig identity. Sine squared x plus cosine squared x equals 1. So we have 1 over cosine x, sine x equals secant x, cosecant x. Well, check this out. 1 over cosine, that's secant. 1 over sine, that's cosecant. Boom, verified that one. All right, so look at this one. Which side should we do? I could try to do substituting sines and cosines over here, or I could try to deal with this denominator over here. And it turns out that it's actually better to work on the right-hand side here. So what I'm going to do is I'm going to multiply 1 plus sine x over 1 plus sine x. This is similar to what we've done before when we were multiplying numerator and denominator by the conjugate. And the reason I'm doing this is in my denominator, I'm going to get, when I multiply this out, I'm going to get 1 minus sine squared x. And we can easily plug in a Pythagorean identity for that one. So let's go ahead and see what happens. So now I'm going to distribute my numerator. I get cosine x plus sine x cosine x. Well, 1 minus sine squared x, that's cosine squared x. So I get a cosine x plus sine x cosine x. Keep the left side the same, so no changes there. So now check this out. I have cosine x over cosine squared x. Plus sine x cosine x over cosine squared x. So what I've done is I've separated my fraction into two fractions. Cosine over cosine squared, that gives me 1 over cosine x. And here I get a sine over cosine x. So I'm just canceling what I can cancel. That gives me secant x plus tangent x. And those are both the same. So that's done. All right, that's it for today's video. Thank you for watching and have a fantastic day.